Students, welcome to the Science 1 class. In this video, we are going to learn about the periodic trends in properties, and it's the continuation of the previous video's concept. Now, we are going to learn about ionization energy. Let me explain what is ionization energy. Let's take a neutral atom, and this neutral atom contains 11 protons and 11 electrons. Now we are going to remove the valence electron, that is outermost shell electron. To remove the valence electron, we should apply some amount of energy. After removing the valence electron, we will be getting a positively charged cation. Here, the energy which we used to remove the valence electron is called ionization energy, and ionization energy is measured in kilojoule per mole. Hence, the definition for the ionization energy is the minimum energy required to remove an electron from a gaseous atom in its ground state to form a cation. It is otherwise called ionization enthalpy. If the ionization energy is higher, then the removal of electron from an atom will be difficult. We know that in the periodic table, when we move from left to right, atomic radius decreases, and it's due to increase in the nuclear charge, and also the addition of electrons will take place in the same shell. When the nuclear charge increases, it will strongly attract the electrons. That's why on moving from left to right, atomic radius decreases. When the atomic radius decreases, it indicates that the valence electrons are moving closer to the nucleus. For example, let's take lithium and fluorine. Amount of energy required to remove an electron from lithium will be lesser when compared to the amount of energy required to remove an electron from fluorine. And the reason is, in lithium the nuclear charge is 3+, but in fluorine the nuclear charge is 9+. Hence, in fluorine the 9 protons will strongly attract the electrons present in the valence shell. Therefore, to remove an electron from the valence shell, more amount of energy is required. So, along the periods on moving from left to right, atomic radius decreases and ionization energy increases. Now, let's see what will happen along the group. We know that the atomic radius increases along the group. That is, while moving from top to bottom, and it's due to increase in the number of shells. So, when the atomic size increases, the distance between the nucleus and the valence electrons increases. For example, let's take hydrogen and sodium. Here, the energy required to remove an electron from hydrogen will be greater than the energy required to remove an electron from sodium, because in the sodium the valence electron is away from the nucleus. Therefore, in the periodic table, along the group, top to bottom, ionization energy decreases. Let me sum up ionization energy. Along the periods, ionization energy increases, and along the group, ionization energy decreases. Now let's learn about the next property, electron affinity. Electron affinity is just opposite to ionization energy. For example, let's take a neutral element in the gaseous state. In this element, we have 9 protons and 9 electrons. And now we are going to add one electron. And what is ionization energy? The energy required to remove an electron. So, electron affinity is the amount of energy lost by an atom when an electron is added to a neutral atom to form an anion. And electron affinity is measured in kilojoule per mole. So the definition of electron affinity is the amount of energy released when a gaseous atom gains an electron to form its anion. For example, when an electron is added to the gaseous state chlorine atom, we will be getting Cl minus ion. So, the amount of energy released during the formation of Cl minus ion is called as the electron affinity. Now, let's see how electron affinity varies along the periods and groups. Along the period, that is left to right, electron affinity increases. Let's see the reason. When we compare lithium and fluorine, fluorine will easily gain electrons because its atomic radius is smaller. That is, the distance between the nucleus and the valence electrons will be lesser. So, when you add electrons, easily it will attract and it will release large amount of energy. That's why when we move from left to right, as the atomic radius decreases, electron affinity increases. Along the groups, top to bottom, electron affinity decreases. The reason is the distance between the nucleus and the valence electrons increases. So, when you add electrons, it will not attract them easily, and the amount of energy released will be lesser. Hence, along the group, electron affinity decreases. Now, let's see the electron affinity of the 18th group, that is noble gases. Electron affinities of the noble gases are 0 because there is no space to add electrons as they have completely filled orbitals or shells. You know that the number of electrons that can be filled in the s orbital is 2 and p orbital is 8. So, when you look at the electronic configuration of the noble gases, they have completely filled s and p orbitals. Hence, the electron affinities are 0. Now, we will learn about the last property, electronegativity. Before learning about the electronegativity, we shall recall what is covalent bond. For example, let's take hydrogen and chlorine atom. Mutual sharing of electrons between two atoms will lead to the formation of covalent bond. Here, hydrogen has given 1 electron and chlorine has given 1 electron and a bond is formed, and this bond is called as covalent bond. After the formation of the covalent bond, chlorine will pull the shared pair of electrons towards itself, and this tendency is referred as electronegativity. The atomic number of chlorine is 17 and has 7 protons But in hydrogen, only one proton will be there, as its atomic number is 1. As chlorine has 17 protons, it will easily pull the shared pair of electron towards itself. Therefore, chlorine is highly electronegative. Here, hydrogen will become H plus by losing the electron, and chlorine will become Cl minus by gaining the electron. So, the definition for the electronegativity is the measure of the tendency of its atom to attract the shared pair of electrons towards itself in a covalent bond. Electronegativity is explained using Pauling scale. Pauling scale was given by Linus Carl Pauling. He was awarded Nobel Prize in the year 1954 for explaining about the nature of chemical bond. He predicted about the nature of chemical bonding between the atoms, that is, whether it's ionic or covalent. Let's see the electronegativity of few elements. For chlorine, it's 4.0, and for fluorine, it's 4.0, bromine 2.8, iodine 2.5, hydrogen 2.1, and sodium 1. Based on the difference in electronegativity, we can identify the character of the bond between the atoms. If the difference in electronegativity is 1.7, then the bond will have 50% ionic character and 50% covalent character. If the difference in electronegativity is greater than 1.7, then the bond will have maximum ionic character and minimum covalent character. If the difference is lesser than 1.7, then the bond will have minimum ionic character and maximum covalent character. Let's understand this with few examples. First, let's predict the nature of the bond in sodium chloride. We have the value of sodium and chlorine in the above table. So, the value of sodium is 1 and the value of chlorine is 3.0. Electronegativity formula is the value of anion minus the value of cation. In NaCl, the anion is Cl minus and the cation is Na plus. So, electronegativity is equal to 3.0 minus 1, which is equal to 2.0. 2.0 is greater than 1.7. Therefore, the bond between NaCl is ionic in nature. Next, NaBr, sodium bromide. The value of Br is 2.8 and the value of Na is 1. So, electronegativity is equal to 2.8 minus 1, which is equal to 1.8. 1.8 is greater than 1.7. Therefore, the bond between NaBr is ionic in nature. Next, NaI, sodium iodide. Electronegativity is equal to 2.5 minus 1, which is equal to 1.5. 1.5 is lesser than 1.7. Therefore, the bond between NaI is covalent in nature. Next, NaF, sodium fluoride. The bond between NaF is ionic in nature. The last one is sodium hydride, NaH. The bond between NaH is ionic in nature. In the periodic table, when we move from left to right, the electronegativity value increases as the nuclear charge increases. And when we move from top to bottom, electronegativity value decreases as the number of shells increases. That is, the distance between the nucleus and the valence electron increases. So the tendency to pull the shared pair of electrons is lesser. Therefore, electronegativity decreases along the group. Okay students, that's all for today's class. Today we have learnt about ionization energy, electron affinity and electronegativity. Thank you students. Have a good day.